It's time to dive into the lesson practice. Let's get started. First thing we're going to need to do is draw a diagram of a circle, identifying a central angle, a minor arc, and a major arc. Now I can do that all in one diagram because any minor arc is going to have an associated major arc, or even better, any major arc is going to have an associated minor arc on the other side of the circle. Here's what this is going to look like. So here's my circle. Notice I have point P at the center, and then all points that are a radius away from point P, same distance away, make up the circle. The central angle is going to be the angle between 2 points on my arc, okay, with P at the vertex of the angle. And if I wanted to make this an actual angle, I would continue these out with a little ray on the end, because these are actually rays. All right, now let's think about this. I have a minor arc and a major arc. Notice how I do arc notation. So my minor arc is this smaller one. This is obviously less than 180 degrees. I say, when I want to note an arc, I say AB, and I put a little arc symbol over the top. Now, for a minor arc, I can name a minor arc with just 2 letters. But for a major arc, I need to choose the 2 letters that make up a minor arc on one side of the circle, and then a point on the other side of the circle between, it doesn't have to necessarily even be on the other side of the circle, it just has to be somewhere between points A and B, between my first 2 points, but inside the major arc somewhere. And the reason I have to name the major arc with 3 letters, I just want you to think about it. Could I name it with 2? If I named it with 2, it would just be major arc AB. But how would I distinguish that from minor arc AB? So here's how this works. Anytime you want to name a minor arc, you use 2 letters. And if you ever see an arc named by 2 letters, you assume that what's being talked about is the minor arc. If you want to designate the major arc, you need to designate the 2 endpoints and a point on the major arc in between to show, hey, you're going this way around the circle instead, not the normal short way. You're going the long way around. So that's how we do that. Okay, let's take a look at letter B. Identify the measure of the minor arc in this drawing here. Notice that my minor arc is RS, arc RS, so I need to go all the way around the other way. Oh, no, I'm sorry, the minor arc is RS. We're just doing the minor arc. The minor arc's measure is the same as its central angle. So the central angle here is 115 degrees. That is going to be the measure of my minor arc. I don't have to do any fancy schmancy to get this one. I just have to select this one. The measure of JK is given by the expression 2x minus 15. And the measure of LM is given by the expression x plus 30. It is given that JK is congruent to arc LM. Determine the value of x and the measure of each arc. Okay, because I know that these arcs are congruent, what I can do is solve a problem setting those equal to each other. So it's just going to be 2x minus 15 equals x plus 30. And then I'm going to subtract x from both sides. It gives me x minus 15 equals 30. Add 30 to both sides, x equals 45. And if x equals 45, let's see, that's the value of x. The measure of each arc, well, let's see. Arc JK is going to be 2 times 45, 90, minus 15. That's going to be 75. And then the measure of LM is going to be 45 plus 30, also 75. Oh, they have to be 75 because they're congruent. Let's see if we got that right. X equals 45, the arc measures are 75. Bingo, bango. All right, letter D. Use the arc addition postulate to write an expression that represents the measure of AB. Well, there's a bunch of ways I could do this. I could do arc AD plus arc DC plus arc CB equals arc AB, the measure of arc AB. I could do the measure of AC plus the measure of CB. That's probably the more arc addition postulate-y way of doing things, because really the postulate seems to imply that we're only adding 2 arcs, even though we could add multiples. So I would do arc AC plus arc CB equals arc AB. Let's see what our author had to say. the measure of arc AD plus the measure of arc DC plus the measure of arc CB equals the measure of arc AB. Works. It works. There's multiple ways to do it. That's definitely one way that works. All right, next, letter E. Find the measure of arc DEG. DEG. So that means that I'm measuring this long arc around the outside of the circle. Now, let's think about this. GD, arc GD, takes up 140 degrees of the circle. And arc DE is a semicircle. It takes up 180 degrees. What's left in the circle? This one I would get by doing 360, so the whole circle, minus 180 is just going to be 180, minus 140, that's going to equal 40. So I should find that the measure of DEG is 40. Oh, wait. Oh, no. I messed up. Let's see. GE, arc GE is 40. Okay? So let's just think this through for a second. Then if this is 40, what is DEG? I'm measuring this large major arc here. I have to add 180 DE to EG to get it. So make sure you're thinking through. Always go back to your diagram or you'll make simple mistakes. I'm actually kind of glad I did that one because that's illustrative of what's easy to do with these sorts of problems. All right, let's just look at the last one. A lamp projects a beam of light over a 100-degree arc. How many lamps facing outward from the center of a circle would be needed to form a full circle of light at the center of a park? What would the overlap of these beams be? All right, so if I want, let's see, 3 of these side by side, if I added them together using the arc addition postulates, 3 of them side by side would be 300 degrees. Then I could add 1 more, that would bring it up to 400 degrees, but that goes more than all the way around the circle. Let's just see, how many lamps facing outward at the center would be needed to form a full circle? There'd be a 40-degree overlap at the end, though, because I only need 360 degrees, but I would have 400. So if I put all of that overlap right at the end, it'd be 40 degrees. Or because there's 4 lamps, the overlap could be 10 degrees per lamp if I wanted it to overlap individually at each lamp. All right, that's how you do this. So these problems are pretty easy and straightforward. You will be working problems number 1 through 30 for next time.